You're about to listen to the Complete Developer Podcast, the podcast by coders, for coders, about all aspects of life as a developer.
I'm Will, the curmudgeonly experienced developer.
And I'm Beej, the optimistic newbie developer.
Complete Developer Podcast is supported by listeners like you. We are now on Patreon at www.patreon.com/Complete Developer Podcast.
Laws, everywhere, laws. This week, we're discussing the laws of programming. We're not talking about legal terminology. Instead, we're going to discuss useful aphorisms programmers have learned over the long years since the first computers. These offer guidance in how you should design software, deal with errors, deal with people, and manage projects. But before we get started, Will, what have you been fighting this week?
I am trying to get a YouTube channel together.
Oh, really?
Yeah, and there's a little bit more to it than I thought. Of course, part of the deal is my graphic design skills suck, and so I have a horrible logo up, and I'm not going to tell anybody where the site is until that's fixed. But I'm also going through Camtasia video editing tutorials and trying to get my skills up on that so that I can start building that. And of course, we're also going to have some stuff here, video wise, eventually, and that's probably going to fall on me. So I've got to figure out how to do that reasonably well, since you're the audio guy.
Yeah.
I
don't want to do video editing.
Yeah. The more I do of it,
too, but
the more I do of it, the more I'm like, I don't really feel this either, but I've got an idea and I want to throw it out there.
All right.
But cool. And I'll announce a little bit more, and that's part of the reason I switched back to Windows. Is you can edit video on Linux, but I couldn't get it to interact properly with the audio subsystems, and I was having a lot of issues with the video because it's NVIDIA drivers, and Linux and NVIDIA don't play nice together.
I mean, I've done some pretty cool stuff just with Windows Movie Maker.
Yeah, but I've got Camtasia 9 or 10. I've got the latest and greatest of that, and so I'm going to be hitting the YouTube, doing stuff on there. So that ought to be fun.
Interesting.
So how about you?
Well, I am finishing up my time on that other project at work. This is my last week on it, and I'll be back on my main project next
Talk
week.
about it, finishing up my time.
Yeah.
I've heard you say that, and I've heard prisoners say that. I guess for the same reason. Yeah,
pretty much. Yeah. I'm looking forward to getting back to the main project. This one was it was interesting. I'll just say that.
It was a conjugal visit from a dumpster fire.
Yeah, something like that. Yeah.
To go back to your prison metaphor.
Also, my life took a interesting turn this week. Yesterday, I got up and found out that my truck was no longer there. It had been stolen. I had to take a personal day to deal with all of that. Guys, there's a lot to do when something like that happens. The police are looking, but not very hopeful. I do want to thank Metro Nashville Police Department. They responded very quickly, and the officer came out and was very friendly, professional, and helpful in a stressful situation. At least it's getting warmer out there, and I'll be able to ride my bike more often. But speaking of warmer weather, I have something along those lines. A product for IoTs. So let's go ahead and roll the music. Make your air conditioner smart. It's a quote from the website for Sensibo. This is a smart controls to allow you to control your heating and cooling through your smartphone. It works with just about any type of unit, wall, portable, even central heating and air. And you can set it to have up to a 7-day schedule for your system, or set it up to turn on as you get close to your home. It's an interesting product. If you just want to see what it's like to have a smart house without tearing out all the insides of your home. I'll have a link to that in the show notes. Who's talking to us this week?
We got a comment on the Code Smells episode 1 from Taranvir Baines. It says, "Hey guys, first and foremost, love your guys' podcast. Keep up with the great work. I do have a request, and it revolves around hearing your thoughts on switching between different programming languages and the difficulties associated with this. At my current job, I'm working in PHP, JavaScript, writing SAS, and also have to switch between C and C++ for my CS courses. At times, I personally want to become a pro at one of these, as I think it would lead to better job opportunities, but maybe being a generalist is better. Thanks in advance.
Well, hey, thanks, Taranvir, for the comment. As Will told me when I started out, generalization gets you the job, specialization advances you in it.
And the other thing I would probably add to that is get better at learning quicker instead of trying to learn more, because, if you try to drink from the fire hose of everything that's incoming on software development, you'll never get anywhere.
You mean like going to med school?
Yeah. But it's worse because there's, it's like saying, okay, I want to go to med school and be a veterinarian and, specialize in ichthyological surgery and, like 500 other things, right? Like get better at how you learn and how you approach things. Mm-hmm. And work on that a little bit before you overly try to generalize. Yeah. Now, as far as the specialization versus generalization, specialization is where it's at. Yeah. If you want to raise that pay rate, that's how you do it. You do have to be careful that you don't specialize in something that's going away. Like if you're a Silverlight specialist or a VB5 web classes specialist, you're going to have a bad time. Mm-hmm. But definitely work towards specialization if you can, at least for the early phases, so that you can raise that income. Because once you raise the income, you have options.
That's true.
You can throw money at problems then. So that's what I would say.
Well, also while you're doing this, send us an email with your contact information at neckbeards@CompleteDeveloperPodcast.com, because we've got a Complete Developer water bottle just for you. Guys, if you'd like your very own Complete Developer water bottle, leave us a review on iTunes or comment on the website or any of our social media. We post all our episodes to Twitter, LinkedIn, Facebook, and Google+. We're also on Tumblr and Path. We've already seen a big increase in the quality of our comments on the website. Keep it up, as we're giving preference to comments when picking what to read each week. In any field, there is a lot of hard-won knowledge that the more experienced attempt to impart on those with less experience. Depending on the field, these things may be called old sayings or laws. They typically aren't really hard and fast rules, but rather are general tendencies that have been observed over time. And programming, like any other field, has those, and many of them are well worth learning. In this episode, we're going to list quite a few of them and just briefly cover them, mainly to get them out there and get them on your radar for learning more.
Yeah, and I'll point out that this is not even remotely a comprehensive list at all, because if I tried to do that, we would have like a 3-episode, and it's not really worth it. Brevity will get you the big ones that you run into. And if you know what they're called, that's just kind of cool to know. If you are able to internalize what these things teach, it will get you ahead.
These are mainly some of the big ones that we think are important. The first one is the Pareto principle.
Yeah, and that's the idea that for many phenomena, 80% of consequences come from 20% of the causes. This is the 80-20 rule.
We've mentioned this on the show quite a few times before.
Like the comment that we had earlier about, specialization. Out of the set of things that he knows, 20% of those things will probably create 80% of his income over his career.
That's true.
That's a reasonable assumption. And that's how this plays out. 20% of your code will generate 80% of the bugs. 20% of your dev team will generate 80% of the work.
Now that is true. I believe that.
Which, of course, the other side of it is that 20% of your dev team will generate 80% of the rework you have to do as well. Mm-hmm. It's a natural, I guess it's like a natural distribution thing with almost like a bell curve type deal. Mm-hmm. Like the part in the middle, the 20% in the middle is 80% of the volume, and give or take.
Yeah. Next is the Parkinson's law. Work expands to fill the time available for its completion, also known as the law of bike shedding.
Yeah, so let's talk about bike shedding a little bit. This comes from a concept of, I think it was somebody that was designing a nuclear plant, right? Like a nuclear power facility. Mm-hmm. And nobody was arguing about the facility, but they decided to build a bike shed out back for people to be able to ride a bike in. Yeah. And everybody argued over the color. It's essentially a thing of the least important things that you're doing are the things that are going to get the most attention and the most argument.
Yeah, because they're the ones that people usually understand the most.
Yes.
And so to feel like they are contributing, they're going to...
Especially the dumbest people that like to argue.
Yeah.
And sometimes that's you, by the way, right?
Yeah,
like everybody has that tendency. Like it's, sometimes you're the dumbest person in the room just because of like your emotional state or whatever. And so the tendency to nitpick kind of goes along with this.
Along with this, too, also goes Hack's Law.
Yeah, and that's named for Phil Hack. He was a Microsoftie. I think he's at GitHub now.
Yeah.
And that's the idea that work expands to overflow the time available and spill on the floor, leaving a very sticky mess.
Yes.
Which is a bit more in line with everybody's experiences with IT project management and scheduling and planning and all those kind of things, because that's pretty much what happens. But the rough idea here is that if you give a certain amount of time for something, whatever work you have is going to fill it up.
Yeah.
At least. And there's a lot of reasons for that. People have a prejudice of, okay, I have enough time to do this. This is something you and I use to our advantage on a fairly regular basis, because I've seen you do it too, where you create an artificial deadline for yourself.
Yeah.
On something. Or you go, okay, I've got to do this morning, and I've got a hard stop at 11, and I'm starting at 9. And you'll get 4 hours worth of work done in 2 hours.
Yeah, that's true. I do that a lot.
Yeah, I do that to myself too. The reverse of these tends to work as well.
Yeah. And the other thing too is something I've noticed so far as like the expansion of the work is it tends to be, okay, I'm going to try out this new way of doing things. And like I was able to add logging into my projects, which now other people at work are adding logging into their projects. The front-end developer I was working with on the main project I've been on, he's started doing a lot of component stuff because he was like the work expanded
right
to fill the time, and so by expanding the work, he added and made a better product. So it's not always a bad thing.
Right. It's just a natural law.
Yeah.
And you need to understand, things like the Pareto principle and things like this. It's an observation of the way things work, and you can bend it however you need to bend it.
Yes.
But it's still going to be there whether you do or not.
Mm-hmm. Now, the next one is, in a hierarchy, every employee tends to rise to their level of incompetence.
Yeah, and I forgot to, in the outline, I forgot to put what this is. It's called the Peter principle. It's named after the Apostle Peter, who was, the first pope.
Uh-huh.
That was his level of incompetence, I guess, although I don't really know what the next rank up is. But it was the idea of, okay, basically, and you'll see this in a lot of organizations. If you have a good software developer, they'll get moved on up, and they'll get to be senior, and they'll get to be an architect, and then eventually they go, well, you're a really good developer. You can mentor junior developers, and they get pushed into management, and stop developing. And well, what happens? Well, if they're not good at management, they don't continue to rise. They don't get demoted either, and so it becomes a evolutionarily stable position for them to be in. So they float up to where they don't float anymore.
That makes sense. You rise until you are unable to rise anymore.
Right. Like a hot air balloon.
Yeah.
There's a point it doesn't go up past because the atmosphere is thinner. And you will see this in your organizations. And that doesn't mean that you go and you talk to management as if you assume that, hey, this person is not actually competent at their job and they are competent at the one right below it. That may actually be a reasonable assumption across a broad swath of the industry, but don't ever go make it.
Yeah, because they may be
on their way up still.
Yeah.
That person may legitimately be CEO material, and hey, maybe it's not a good idea to take them off if they are. That's
true. Next is Murphy's Law,
which states that at any time BJ's laptop is opened, Windows will be updating.
That is so true.
It means anything that can go wrong will go wrong. And if it's your laptop, Windows is updating.
Yeah.
Because that's what goes wrong on your laptop so far.
I think Murphy's Law is a pretty well-known...
yeah. I mean, it's not really necessarily a thing with programming alone, clearly, because it's probably older than programming. Another thing to think about this in terms of is things like when you're dealing with error handling, right? Like, let's say you're reading from a file and suddenly the file is no longer accessible because somebody, back in the old days, pulled the floppy disk out. right? Like that can happen and it will eventually happen in your app. So always be bearing these things in mind that bad stuff will eventually happen, giving, like uncommon events become common at scale.
Oh, yeah.
So think, that's the other corollary of Murphy's Law is it scales up into, the law of small events over a large area.
I heard a very junior developer today at work say something like, oh, well, the user will know this, and just the entire room burst out laughing at her. And it was like, the user's going to know exactly what they're supposed to do. You can't assume that. You can never assume that. Always assume that they're going to do the exact wrong thing.
Because one of them will, eventually. Yeah. And so it's, Murphy's Law, teaches you to plan ahead for things that may happen to you at a point. But in programming, it's also important to realize it will happen to someone at a point.
Yeah, that's true. It's very true.
And also to never open BJ's laptop unless you want a vortex of Windows updates.
Yeah, it doesn't matter. I'm like, I could have updated it before coming over here.
Right. You could install Linux on it. You still get a Windows update, I think.
Yeah,
somehow.
Probably. Yeah.
There would be some way that a Windows update would come in through wine or something and nail you. You could be on BSD and be like, "What's this?"
Yeah,
that's your laptop. There would be the one Windows update that gets deployed somehow to all these other systems.
Yeah,
and it would hit your laptop, guaranteed.
Exactly. Next is Brooks Law, which is adding manpower to a software project will make it later.
Yeah, this is something I run into with project managers a lot, and they really, of late, when I say this, I find that they get more and more offended, so eventually we'll have to stop saying it, but I'm going to say it on the podcast anyway. Mm-hmm. You cannot put 9 women in a room and say you're going to have a baby in a month.
Unless one of them is 8 months pregnant.
Right. Throwing more people at the problem doesn't make it go faster.
Yeah, we had this issue. We're recording on Wednesday, which is a little odd for us because I was sick Monday. But we had this issue this week on this project with a really tight deadline where our director said, well, do I need to put another developer on this project? It's like, we have a week to finish.
No.
Yeah. It's like, it'll take him that long. And we said, it'll take him that long to get caught up.
The way I like to explain this to managers, if you've got somebody that's an engineering mindset, is instead of going, okay, I have a number of people to do something, I think of it like a chemical reaction or heat reaction. In other words, how long does it take this person to become exothermic?
Yeah.
Because if I drop an ice cube into a fire, it doesn't make the fire burn hotter. Or if I drop frozen hydrogen into a fire, it's not going to immediately cause the fire to get bigger. It's got to melt that ice first. And that's what you run into with these teams is, I'm just going to throw more people at it. Well, now the rest of the team is having to put the heat into them instead of into the thing that they're doing.
Of course, we then ran into the problem of me being out all day yesterday. So they're like, well, maybe we should have thrown another person in there. I'm like, no.
No. Then you would be even worse in the hole.
Yeah.
That does not work. You do that early and you train them. Mm-hmm. You don't do it late. And I'll add as an aside, if you're ever on a recruiting gig where you're brought in at the tail end of a project like that, it's a fair bet you're brought in to fail. If you weren't brought in to fail, then they're just dumb, which means you were brought in to fail.
Yeah, well.
I don't want to be overly jaundiced about that, but I've had that experience a few times. It never goes well. The next one is Linus's Law. This is named after Linus Torvalds.
Speaking of Linux.
Yeah. It says, given enough eyeballs, all bugs are shallow. And the reason is everybody comes at things from a different angle. Or, you get enough people, you have enough different angles. And they can look at the bug and somebody will figure out what it is, especially somebody that is annoyed by it. Mm-hmm. And that's part of the reason Linux is as stable as it is, provided you don't have NVIDIA drivers, is because you've got enough people looking at the way everything interacts.
Yeah, well, sometimes, speaking of bugs, sometimes you'll have QA that says, oh, this is simple, you can just do this. And happened to me today in a meeting. I looked over at the QA person who was sitting beside me. I said, oh, it's simple, you can do it.
Yeah.
No? Then it's not simple.
Yeah.
You don't know
we
what's
call
involved.
it, we've gotten, at work, we've gotten to the point where somebody says, just do this, or it's simple, and we call them out on it immediately.
Yeah.
because that's verbal diarrhea. It's not simple. Why doesn't NASA just build a Martian base? Why don't they just do that? What's taking them so long? This is simple. All you got to do is have containment, and you could have a population there, like in not Terminator. Which Arnold movie was it?
Total Recall.
Total Recall. Yeah, you could just totally do that. It's simple. Why don't you do it? It's not simple, or we do it. Stop saying that. That said, if you have enough people running into something, especially technical people, somebody's going to start figuring out a way around it because they're motivated to, and there's enough of them that, it's essentially the reverse of Murphy's Law. It's not.
Yeah, that makes sense.
Yeah. It's the bad things are happening, and eventually good things will be made to happen to get rid of the bad things.
Well, it sounds more like a reverse to Brooks' Law.
Well, it's kind of a mix.
Yeah.
It could be
this isn't adding manpower to a software project. This is enough people seeing a problem
that somebody fixes it.
Yeah.
And the next one is Kirchhoff's principle. This is a little hard. The name is just hard to pronounce. And that's in cryptography, a system should be secure even if everything about the system, except for a very small piece of information, that would be the key, is public knowledge. This is the way encryption systems work. This is the way your hashing algorithms work. The system is secure because the algorithm is designed in such a way that unless you have a critical piece of information that isn't known, it isn't part of the algorithm, it's a piece of data that goes in, you can't break it. Mm-hmm. In other words, it's math.
Yeah, I gotcha.
That makes that a thing. Like you protect it with math, you don't protect it with secrets. As far as cracking the algorithm, people implementing it use the secrets.
Okay, I follow you there. Yeah.
Yeah, it's a core principle in cryptography. And you will run into this. You'll also see that as computers get more powerful or people get more clever, that you'll find that algorithms become less and less secure because that principle was not actually observed. It's sort of like a pure libertarian society or a pure communist society. It's something that doesn't exist.
Yeah.
So, you have to bear that in mind, but it's a pretty important foundational principle of encryption.
Next is Conway's Law. That's any piece of software reflects the organizational structure that produced it.
Yes. And I have an example where I work. We have the Delphi side and we have the .NET side. Mm-hmm. And there's very limited communication channels between the two.
Yeah, that makes sense.
They don't share libraries or anything. Why is that? Well, we've got the .NET developers over here doing .NET things. We've got the Delphi developers over here doing Delphi things. And there's not people that really cross over. I'm starting to cross over. What's happening is that's happening. Communication channels are opening up. And organizationally, they're opening up, but we're also learning how to talk to Delphi from .NET and vice versa, and being more considerate of how the other one works. It's the shift in organizational structure is shifting the code structure.
Yeah, okay.
You'll see that the code structure is an artifact of organizational structure. And eventually, if you have a code structure that is deformed enough, you will also deform the organizational structure. Mm-hmm. Those two things are tied together. There's no seam.
Okay. Where I work, they brought me in part because I have the C# and the JavaScript knowledge in Angular, and so I'm able to work pretty full stack for what we have, because I can even do some SQL if need be. I try not to do very much of that because our DBAs are really good about, you ask them, hey, I need a table, I need this built, and it gets done.
Yeah.
And they know a lot more about that than I do. Like, when I talk to them, I always learn stuff. So, I like going to them and asking them to do stuff because I'll learn about database structure and stuff like that. But one thing that we're doing is we're starting to cross-train the other developers. And we have a fairly young crew of developers. A couple of our senior developers are older, but everybody's really interested. Like, even the oldest senior developer we have is a .NET developer, C#, and he came in and sat on a class on Angular with us today.
Yeah. And you'll start to see that, eventually probably what will happen to you is your Angular projects will get pulled into .NET. In other words, you'll have the .NET website and you'll also have the Angular project, and it'll be a project crammed together, not a separate
I don't think we're going to do that. They don't want to do that.
They don't want to right now. And there's very good reasons they don't want to. It could happen, is what I'm telling you. I've seen it work. The other thing you may end up having is a situation where the .NET developers build wrappers that the Angular people use.
Yeah. No, we've done some of that.
Yeah. So it's already happening.
Yeah.
It doesn't necessarily manifest the same way, but what it will do is you'll start to see the organizational structure respond to the code structure and vice versa.
There are a lot of conversations of, oh, well, we need the information in this manner. It's like, okay, well, I can adjust the API to send it to you that way, or we can adjust the front end to like what the API sends. It's like, all right, where is the least amount of work? And as the Angular developers are learning the C# and the C# developers are learning the Angular, we're getting better in that communication of, okay, well, let me do that on the back end because it's less work to do it on the back end than it would be for you to do that in your Angular controller.
Now, were they to separate the teams and put a wall up between you and say you couldn't talk?
So that would be weird because
it would be weird. It would be stupid.
Yeah.
Also, but were they to do that, you would see those projects start to separate because you don't have a communication channel between the people.
Yeah, that's weird. And this is the thing. Our teams are typically a front end and a back end developer. Like we have like 2 developer teams. Of course, we all work together and help each other out because we're all using the same like services and stuff.
Yeah, your lines are going to get blurred.
Yeah.
And if you really want to be powerful in your organization, the next thing you'll do is you'll start talking to the SQL developers a lot, like going to lunch with them, doing that kind of stuff, because all of a sudden now the database can be brought in, and you'll be at a leverage point between those two things. So going to the next law, which is Moore's law, and that's the idea that the power of computers doubles every 24 months, or the number of transistors on an integrated circuit board will double in about 18 months.
There's been a lot of controversy around this as it is starting to slow down because we're hitting physics.
Yeah, and the other thing we're learning is that, hey, if as we increase the number of transistors and the amount of throughput that we do, we're also creating heat. And heat's not a real big deal when you have one computer in a room, but when you have a data center, it's a problem.
Yes.
And so Moore's law is going to be a law until it isn't. Now, that said, from a predictive analysis standpoint for the near future, we can predict that if you get a laptop computer that is 24 months younger than your current one, you can get a Windows update done in like 2 days.
Yeah.
So, looking forward to that,
Me too.
You could probably speed the thing up realistically by passing TCP/IP packets by carrier pigeon. But,
yeah,
I'm hopeful for you, man. So, like another 20, 30 years, you'll get a Windows update at the same speed as everybody else.
I know.
You won't know what to do with yourself.
It's going to throw me off. It really is.
It will. It'll throw it off realistically, there's probably going to be a black hole.
Yeah.
Just open up somewhere if you get a faster computer.
Be a singularity.
Yeah. And you know what you'll find when you go to the core of that singularity under the crushing pressure? Another Windows update.
Always. Next is Wirth's law, and this is software gets slower faster than hardware gets faster.
Which has a corollary with your machine and Windows updates. So see, we're just, we like to square the circle here at Complete Developer Podcast. And that circle is squared all around it.
It's a bit more rectangular, but
it's for particularly large value of a circle, it's a square, right?
Yeah. Well, there you go.
The next one is Zawinski's law, and that's every program expands until it can read mail. Those programs which cannot so expand are replaced by those which can. That's kind of dated from like the 90s. The programs can get to the point where they can read email, because this happened with Netscape. I don't know if you remember the whole suite of crap they put on there. I
remember that, yeah.
And then eventually, like, Netscape, found its Schwarzschild radius and became Firefox.
Yeah.
Or whatever. I think it was Firefox. Yeah. There was morphing and all this stuff, but it shifted into something else, and then those things expand again. There's typically a feature set that is the peak feature set software in a particular area, and the piece of software will get up to that level of complexity, and then it will collapse.
I'm already writing software that sends emails.
Yeah. Well, when you start reading it, then get braced.
Yeah.
Of course, that's also based off of the 90s, right?
Yeah, that's true.
That's kind of an older rule, but it's basically a tendency of software to get overly complex and eventually get to the point where it cannot get any more complex, and something less complex that does the new thing replaces it.
No, we've seen this with JavaScript frameworks.
Yeah. You'll see it everywhere once you start looking for it.
Yeah. I mean, even the migration, or even between versions in like Angular 2 is a lot less complex to use than Angular 1.
Right. It's kind of similar to the principle in ecological systems that when a system gets disrupted, like let's say you have dinosaurs and you have a meteor strike, right? The less complex animals are the ones that take over.
Yeah.
After that, think about market forces in a similar fashion, and it kind of makes sense. They get complex enough where they're apex predators and they're 18 feet tall and 40 feet long, and they're eating other apex predators because they're so big. Something disrupts that system. Now you have rodents that take over, and eventually they grow up into what we have now.
MySpace.
Yeah, exactly.
Because Facebook and Twitter came out and they were much less complex systems. So you remember MySpace, you could change your background, you could have it autoplay music, stuff like this.
You can make it really, really obnoxious, and then Facebook took over, and
you couldn't do any of that stuff.
Right. And Google Plus, you can't even get an audience.
Wow, nice. I like it. That leads into the next law, which is Fitt's law. The time to acquire a target is a function of the distance to and the size of the target.
Right. And this is why the edge and the corners of your screen are the most important real estate on the screen. That's why they put buttons like minimize and maximize and those kind of things there. Because what happens? Your mouse cursor can't go any further.
Yeah.
Right. That's the stopping point. That effectively makes that target size infinite.
True.
That's why it's like that.
Okay. That makes a lot of sense.
It's a weird way to think about it, but if you go as far as how do I move to this target, any distance past, if I'm X pixels from my mouse cursor to that edge, if I go X plus any value, I'm there all the way to eternity. So that's a very valuable target area. That's why they put so much stuff around the edges. Okay. It's weird to think about it that way, but that's give or take what it is.
I thought it was just to get it out of the way of the main content. But that makes a lot more sense.
Yeah.
Okay.
That's why stuff is in the corner, especially your critical controls.
Oh. Next is the 99 rule. The first 90% of the code takes 10% of the time. The remaining 10% takes the other 90% of the time.
And I'll also add that this is, I don't know if it's quite recursive. Yeah. You're really never actually done with a program.
That's true.
Right. You just keep on taking smaller and smaller slices until eventually somebody screams at you to release it. That's how the whole industry works.
Well, something I've noticed when I read through your outline, I was thinking, I was like, 90% of the code is the setup. Like the building the pieces so that you can do that one critical function that takes 90% of the time to write.
Yeah.
Getting it right.
Or it's boilerplate, or it's, user management, or it's stuff that you generate. I mean, that's just the way it works. And also think about like the libraries that you're bringing in.
Yeah, that's true.
I mean, the bulk of your code isn't written by you anymore. It's just a weird thing to think about. The next one is Knuth's optimization principle, and that's Donald Knuth. Premature optimization is the root of all evil. But basically the idea is that if you don't have heuristics for knowing how much time you're spending on something, or how many CPU cycles, or how much RAM, if you optimize it right now, you will be wrong to do that, because more than likely something else is worse, and you may actually be getting in your own way.
That's true.
That's why he's like, hey, look, measure it, then deal with it. And it's a premature optimization if you're optimizing when you don't know what the problem is, or you don't know if you have a problem. Because it's also more optimal to go and build a new feature that makes the company more money. If, this thing is, this thing's using an extra megabyte of memory. Well, I could try to optimize that out, but I have I have a system with like 32 gigs of RAM. Nobody's going to pay me to trim that megabyte off. They might pay for another feature though. So it's just in the general interest. That's also why software gets slower faster than hardware gets faster. That's why that happens. The next one is Hofstadter's law. And that is the concept that it always takes longer than you expect, even when you take into account Hofstadter's law.
It's always going to take.
And the nice way to put this is developers and project managers and basically everybody sucks at estimation, including your GPS system. It's like, it's 20 minutes by car in light traffic. Well, it's actually 20 minutes and 30 seconds. And if you thought it was going to be 20 minutes and 30 seconds, it's 21 minutes.
Yeah.
And part of that has to do with your adaptation to expectations. That is now a variable that affects the output.
Yeah, there's a way to get over that 20 minutes and 30 seconds. You just drive faster.
Yeah.
The next is the law of Demeter. This is the law of least coupling.
Yeah, and this is something in computer science. Typically, most of these laws are kind of cynical.
Mm-hmm.
But this is something you actually do need to really remember. That is don't tie things to things that they don't need to be tied to. Just as a general rule, like don't do that. So there's 3 pieces to this. The first is that each unit should have only limited knowledge about other units. Only units closely related to the current unit. So the idea is hey, don't tie your MP3 player to your network card. Because that's dumb. Because you changed the network card out, now you got to change the MP3 player. Don't do that. Because why would it care? Now, it cares a lot about the audio system, or whatever subsystems are involved there, but it shouldn't care about something way out here.
Yeah, each unit should only talk to its friends and not talk to strangers.
Yeah, and that's the other thing, right, is it shouldn't care about the web server that the network card is talking to.
Yeah.
Which is even worse, because that web server may give it bad instructions.
Mm-hmm.
And, basically, it's the idea of a piece of software should only talk to its immediate friends. Known sources, small surface area, don't tie too tight. And then you can make it when one of those pieces gets switched out or becomes hostile or whatever. And this goes all the way, down at like the driver level and the kernel. The kernel does not trust the drivers.
Yeah.
Well, or you get crashes. The operating system doesn't trust the applications running. The computer doesn't trust other computers on the LAN. Your LAN doesn't trust other computers on the open web.
Yeah.
The open web doesn't trust Kim Jong-un's computers.
That's true.
And vice versa.
Yeah.
This scales all the way up.
Yeah, it really does. It really does.
Because neither one of them, it doesn't make sense for them to trust the open internet either. It minimizes the spread of contagion of various sorts.
Of course. Next is Hanlon's razor. This is actually a corollary to Murphy's Law.
And Occam's razor.
Yes. That is, never ascribe to malice that which can adequately be explained by stupidity.
Right.
I've heard this referred to Microsoft on so many occasions.
Yeah. Microsoft, we shave with Hanlon's razor. No, but it's true of any group of users you have, right?
Yeah.
If you go into the mindset of, okay, they did this to the system and they broke the system, it's obviously because they're trying to screw me over. You're not going to be able to solve their problem.
Yeah.
Just because your emotional state. But the other thing is you're probably going to be wrong about where they're coming from. This is somebody that, is probably somebody that picks up the keyboard and shakes it trying to get the computer to do something. You can get mad and you go, oh, they're malicious, but they're not malicious. They're idiots. Don't react to them like they're malicious. That's not going to inform your approach. What?
We shave with Hanlon's razor.
Do it. And obviously the next one is the Dunning-Kruger effect. And that's basically, they have a better way of putting it, but if you're an idiot, it's sort of like being a dead person in the Sixth Sense. You don't know it.
Basically, unskilled people tend to mistakenly assess their own abilities as being much more competent than they actually are.
Yeah. And that includes all of us.
Yeah.
Because, you don't want to look around and go, yeah, I'm just terrible.
Mm-hmm.
That is something a human psyche will resist. And as a result of that tendency, you have a lot of people who think they're very, very competent, very, very smart, and they're terrible.
Yes. And
they're using your software. Bear that in mind.
Or they work with you.
Or they manage you.
Yeah.
Or you manage them. When you manage them, that's the scariest one.
That's true. That's true. Just remember, though, this is easy to fix because once you're in the Dunning-Kruger Club,
you get kicked out.
Yeah. Next is Postel's Law. Be conservative in what you do. Be liberal in what you accept from others.
Yeah, and this typically applies to, things like networking or API interfaces, right? Mm-hmm. In other words, if you send me a bad packet, I don't need to blow up.
Yeah.
Because of the bad packet. If I send you a packet, I need to make sure it's shaped right so you don't blow up.
Yeah, that makes sense.
Right? There's an asymmetry there. However, in interpersonal relationships, this also applies. It applies a lot to tech people. As a matter of fact, a pretty good chunk of the tech people out there have this exactly backward.
Yeah, that's true. That's very true.
And they cap their income accordingly.
Next is Eagleson's Law. Any code of your own that you haven't looked at for 6 or more months might as well have been written by someone else.
Who was the chairperson of the Dunning-Kruger Club?
Yeah.
On average. If I look at my old code, that's what it is. I
will tell you, and I know I've mentioned this a couple of times, been going back and fixing some things found in UAT in the very first project I worked on at my job, and I look at the code, and there are sometimes I look at it and I go, especially the Angular code. Yeah. I'll look at it and I'll go, oh, is this where the other API developer was trying to learn Angular? Then I look at the commit history and I'm like, no, that was me.
No one else has touched it.
Yep. Oh,
yeah. That's why I always like to get people to look at my bugs. That way that they're the last one that touched it. And if I don't actually look at the diffs, I can assume they did it. It feels way better. Yeah, just wait. You'll start doing that too.
Yeah, I'm sure I will.
Well, and it also keeps you from, the particularly stupid errors, that'll get rid of those. And then you can also go, well, they probably screwed it up. I'll just fix it.
Well, I will also say this. I spent probably a good hour today trying to figure out why a particular endpoint was it wasn't receiving a payload. It's like I had Postman open and I'm calling to the endpoint and I just couldn't get to work. I called over another .NET developer and had her look at it, and she's like, well, here, let me give you what I'm sending to a similar endpoint, because this is the one that a service is calling. And so she's like, well, let me show you what I'm sending. And hers went through and worked just fine. It's I'm trying to make mine work. I'm trying to make mine work. You know, I got down to within the object within an object, I'd missed a comma.
Yep.
And I wasn't getting any kind of errors or anything. It just, was like, oh, this is wrong.
Okay, so the next one is Dilbert's Law, and this is a corollary of the Peter Principle, said with a little more cynicism. Light dusting of cynicism, actually. And Dilbert's Law is that incompetent workers will be promoted above competent workers to managerial positions, thus removing them from the actual work and minimizing the damage they can do. This is said in jest. What actually happens is, if you're evaluating it that way and you're looking at your manager and going, they got promoted so that they wouldn't do more damage, probably what the deal is you don't realize that they're providing a different value and they got moved to a position where they can use that value. Some people do, get promoted, to reduce the amount of damage, but most of the time they call that a downsizing.
That's very true.
That, it doesn't make sense the other way. It just looks that way. If you're focused on this thing and they're focused on a bigger, if somebody that's looking at strategic objectives looks dumb to somebody that's looking at tactical ones. If you're storming the beach at Normandy, it seems like a really dumb place to be, but it wins the war.
Yeah, that's true.
So, play with these and then go, okay, yeah, this is funny and haha, but also think about how your own unintentional bias plays into these, because it matters.
Where this becomes, where what you were talking about becomes a problem is, we have our lead DBA that's in some of the projects, and he will be in a meeting and he wants to talk about the enterprise level of things, and it's no, that's great when we're kind of early on and we're planning things out, but we're in a meeting where we have to figure out how we're going to get all the work that needs to be done by the deadline that's the end of this week.
Yeah.
We don't need to be talking about things like, how is this going to connect to a service that hasn't been built yet?
Right. But if you hear somebody talking that way, it looks like the Dilbert principle.
Yeah.
Because, in that case, it kind of is.
Yeah.
So the next one is Sayre's Law, and that's the idea that in any dispute, the intensity of feeling is inversely proportional to the value of the issues at stake. This is another bike shedding law.
Mm-hmm.
And I would agree with that. This is why when you lay out how an application is going to look, this is why I use tools like Pencil Project or those that kind of do like a janky looking sketch. It's here's where the pieces go.
I learned this the hard way.
Yeah.
The very first project I did for one of your clients.
Right.
Because I went.
You went full med student.
I did.
And the problem is that, okay, whether this button is got rounded corners or not doesn't matter to the scope of the project.
Mm-hmm.
Where the button is placed matters a little bit in terms of usability, but rounded corners are not so much. You'll notice that if you start putting stuff out there and you try to make it really pretty, that people will argue over whether those corners should be rounded more than they'll argue over, hey, do we need to use, do we need to store passwords? It's a weird, I think it's a lot of people that don't have a lot of value to add, like to argue.
Mm-hmm.
And the other thing is people that feel like other people are going to win those arguments will jump in with the little stuff, and you have like this race to the bottom. And so you need to bear that in mind when you're planning stuff. Yeah, I know you've seen it, and I've seen it. Oh, man, have I seen it.
See, and this thing is not just in software. I've seen this in other areas. Like everywhere.
Well, you and I grew up Church of Christ.
Yeah. Let's say every field I've ever worked in and a lot of volunteer places I've been at, this is an issue.
Well, I mean, you'll see this in, like radical groups of any group that, that gets a really hard opinion, takes a hard line on something. Who do they fight with the most?
Each other.
Yeah, because there's a slight variation. Because these other people, they're other people, but you're family. So we're going to beat on you more.
Exactly.
And it's just a weird quirk of human behavior. And if you're doing software development, you get to deal with this at a higher rate of speed than most people do.
The next one is the abstraction principle. Each significant piece of functionality in a program should be implemented in just one place in the source code. Where similar functions are carried out by distinct pieces of code, it's generally beneficial to combine them into one by abstracting out the varying parts.
Yeah. And this is a core principle of software development. Like, do stuff in one place.
Yeah.
Don't do it in 100 different places. Part of the reason that, if you look at a house that has been condemned, that's had, bums living in it, let's say, part of the reason is they don't just use the bathroom in one place. It's they use it everywhere. And as a result, the whole thing gets crappy.
Literally.
And and if you've ever been on a software project where people didn't understand abstraction, you're well aware of what that feels like. I don't know. I didn't have another analogy to pull out on that one, clearly.
Yeah. Next is the KISS principle.
Yep. Keep it simple, stupid. In other words, don't make a system, apply Occam's razor to any abstraction you're using. Don't make it more complex than it has to be useful. And this is a gripe I have with the way mathematics is presented and the way comp sci is presented as well, but especially math, is there's a lot of stuff that you can understand the general principle and apply it without having the symbols, but they give you the symbols first. And it's a thing that isolated communities with their own language do. They have a way of putting stuff, and you're like, no, I just wonder if like plumbers do this. Do they go, do they have some formula for how crap runs downhill in a pipe and argue over it? I doubt that, but maybe that exists. But it seems like in like the technical professions and stuff, we have these ways of saying stuff that make it so much more complex. And you also have to think about that. Okay, you're now writing code that somebody else is going to look at. You need to not do that. Part
of this comes out of the need for precision.
Yeah, it does.
In your language. And it's an abuse of that.
Well, it's knowing who you're talking to.
Yeah.
And I'll give you another example. Elementary school teachers. Can I go to the bathroom? I don't know. Can you? Well, okay, it's an accepted language construct that I don't have to say, may I go to the bathroom? It's, can I go to the bathroom? They're being precise and pedantic and technically correct, but they don't realize they're in a conversation with a child. Or they do realize that they're just being jerks. But, like that, the simpler way to put it makes the thing get understood.
My favorite response to that was, never mind, just did.
Yeah. See, I think if I was as an adult, if that happened, I think I would honestly just start dragging the trash can over and looking at them, going, "Are you going to look away?" I just, but it's that mindset. And what's interesting to me is that in software development and in other industries like ours, we'll complain about teachers talking that way, or we'll complain about people in general talking that way, mathematicians or whatever, and then we go do that to other people, including other developers that have to look through our code. It's just not, it's not a good way to be a member of the ecosystem, because it's going to come back around and bite you eventually.
Finally, Brandolini's law.
Right.
Also known as...
I'm going to edit this for the kids. The bullcrap asymmetry principle. That is the amount of energy needed to refute bullcrap is an order of magnitude bigger than that needed to produce it. And if you don't believe that this is a thing, just read the tech industry press. Any of it.
Mm-hmm.
There's a lot of stuff that comes out that somebody goes, oh, well, this new thing is going to revolutionize all the things. And how long did it take them to write it? And how long is it going to take you to prove that, no, this is complete and utter garbage? This isn't going to revolutionize anything. In fact, this was already tried in the 1930s with, catastrophic fatalities. Probably not quite at that level, but, something along those lines. But it takes you got to go to Wikipedia, you got to look it up, and all they got to do is assert.
Well, this goes back to what I was talking about with the QA tester that was like, oh, this is simple, you can just do that. And where I just looked at it, I was like, oh, it is? Then you can do it?
Yeah.
This is where, rather than refute the simplicity,
this is an issue of framing.
Yeah.
Is what that is. You are not allowing their frame to take over.
So this has sort of been an overview of the different laws of programming and how they are used.
And these things will come up in discussions all the time. And if you're around a while, you'll hear every one of these brought up at some point.
Again, this is not an exhaustive list. We put together some of the most important ones that we could think of to cover them all. We really didn't go into deep details about any one law. You might be on the lookout for some future episodes where we do go into details on one or a few of these laws. And if there's one that you'd like to hear more about, leave us a message in the comments and we'll start working on an episode to talk about that. That pretty much wraps us up before we close everything out. Will, what do you have for us this week for Tricks of the Trade?
Well, as Beej was talking about with the coworker that suggests that something is just, you just do this or this is simple. I want to introduce a concept that probably come up to some degree in a few other places. I know John Sonmez has brought this up innumerable times, and that is the concept of frame. And the idea behind this is that the way you look at the world, if you are strong in the way that you look at it, you don't get it shifted by other people who probably don't have your interest at heart. If you start to be aware of that, you'll start to realize who the natural leaders are in whatever group you're in. Those are the people that have the strongest frame. In other words, they're able to pull other people into their frame instead of being pulled into theirs. And that is probably one of the best ways that you can avoid a lot of the bullcrap asymmetry is having a strong enough frame to do like BJ did and go, oh, okay, you think this is simple. Why don't you just do it? In other words, put them in a position where the script that they're running doesn't work. And this concept comes out of neurolinguistic programming, which is I don't know if it's still psychology or if it's pop psychology. As a general principle, it seems to work pretty well. I think a lot of the directions they've taken it are probably a little dicey, but it's something to bear in mind. And when you get to a level of confidence and a level of skill where you know what you're doing, you should make sure your frame appropriately reflects that. Otherwise, you're going to end up in a situation where you're having to live in somebody else's, and that can be pretty miserable. So just want to throw that out there as something that you may want to look into. Just if you do go look it up and get into the NLP literature, be a little careful about some of the crap that they say. Bear in mind that these are people that understand the concept of frame, and they're also trying to bend you into theirs. That's all I got.
Stand by for Titanfall.
If you have a question or comment for us, please email us at neckbeards@CompleteDeveloperPodcast.com. Our theme music is an excerpt from Stand By for Titanfall by Pure Bells, available on SoundCloud and licensed under Creative Commons. The intro music for IoTs is Hillbilly Hip Hop by Jason Belcher. For references, show notes, and to sign up to our email list, be sure and check out the website at CompleteDeveloperPodcast.com. You can also follow us on Twitter at CompleteDevPod and like our page on Facebook to keep up with the news about the show. Thanks for listening. See you next time.